Let us look at the constant keyword in C++. So there are various usages of constant keyword. So const qualifier, the first thing is you can declare constant identifiers. Let us say const integer x assign value 10. Next I will write x++. Let us see what happens. So if you have any constant values, then you cannot modify them. So you can read a message here that cannot assign to variable x with the constant qualified type const int. So this is an integer constant, so you cannot modify it. So the value of x cannot be changed. Even I cannot say x assign some other value like 30. It's also an error. So you cannot modify this identifier x. So const int is the method of declaration. So is it possible that I declare int const x? Yes, that's also same thing. Even I can write const int or int const. So it is like this. I should read it from the right hand side. This is a identifier x of type constant integer. Or else if I write const int and if I remove this from here, then let us read it. X is an identifier of type integer constant. So both are the same thing. So a constant identifier when you declare, you cannot modify it. If I remove const, then I can do that. I can access this value x, I can modify it. So const values are just meant for being used, we cannot modify them. So I can say cout x and the x value will be displayed. So I can use x, but I cannot modify x. You can see here the value 10 is displayed for x. So this is a constant identifier. Let us move next. Second usage of constant. Now next usage of constant. See, I can have a pointer, integer, star, ptr, assign ampersand x. So this pointer ptr will be pointing on a variable x, right? Then I can say cout star ptr. I can print the value. And if I want, even I can increase the value of x. So let us say plus plus star ptr. So the value of x will be incremented and it will be displayed. So I am accessing it. I will display x also and show you. X is having value 10 and the pointer is pointing to x. I am increasing the value of x using the pointer and I am displaying the value of x using the pointer, as well as directly I am displaying the value of x. Let us see what happens. X was 10, then it should become 11 and 11. Yes, through ptr also it's 11, through x also it's 11. So I am able to increment the value of x. See, already I have some variable and the pointer. Everything is ready. Now let us learn about constant. So I will make this as constant integer. Now x is integer, so now you can see that cannot initialize a variable of type int star with an r value of type const int. So you cannot store the addresses of constant identifiers to the pointer. So can I have constant pointer? Yes, we can have a constant pointer. So let us read it from the right side. See, pointer of type integer constant. So it is a pointer to a constant type integer. So you can assign it to x, but you cannot modify because x is integer constant, so the constant value cannot be modified. So you can see that read-only variable is not assignable, so you cannot modify this x because x is constant and the pointer is also constant. Now let us see next thing. I'll remove constant from x. X is not constant. Will this error go away? No. Still the pointer is constant. So pointer says that I am constant pointer. I will not modify the values wherever I am pointing. So yes, using a constant pointer means it cannot modify the value. Yes, this is an error. So without this, it works. Even though the identifier to which this pointer is pointing is not a constant, but the pointer is constant, so it cannot modify the value of that identifier. Let's run I will get the value same 10, 10. So I cannot modify that x. So we have learned what is constant identifier, and also we saw a constant pointer. So this is a pointer of type integer constant. So it's a pointer to a constant. So you cannot modify the data where pointer is pointing. Now let me show you next. Now let us change something here. Instead of writing constant there, can I write const here? Yes, it means the same thing. So it's a pointer to a constant integer, or integer constant means the pointer is pointing to a location where it's not going to modify the data. Now let us see a next thing. If I have integer type variable y to which value is 20, now can I say this ptr assign ampersand y? So it means the pointer was pointing on x, now it will be pointing on y. Yes, you can change the pointer to point on some other data member. It is possible. But you cannot modify wherever it is pointing. Now can I modify this one? Can I say plus plus star ptr? No, I cannot modify because pointer is of type constant, right? So integer constant, it cannot be modified. So we learn this thing. Now, third usage of constant. So I have shown you two things. Remember, I have shown you constant identifier, that is integer is const, that is x was const. Then again, next I have shown you a pointer to an integer constant where the data cannot be modified by pointer. Now the third thing I am going to show you, I'll remove a pointer from here and I will put a pointer here. Let us read it. What does it mean? Pointer constant. So pointer is constant of type integer pointer. So this ptr is a constant and it is of type integer pointer. So this means that this pointer ptr is a constant. So this pointer cannot be moved to some other variable. So if you make ptr move to some other variable, it cannot be done. So you cannot see, you can see that cannot assign to variable ptr with const qualified type int star constant. So it means I cannot assign ptr to some other variable. So it is bound with this variable x only. You cannot move it from there. It means, can I change the value of data? Let us try. Plus plus star ptr. So can I change the value of x? Yes, I can change the value of x, but I cannot move the pointer from variable x to variable y. So once the pointer is assigned to x, it cannot be moved from there. So this was the third usage of constant. Now let us see the fourth usage of constant. I will write constant here also. Then I cannot do both the things. So it's a constant pointer to an integer constant, right? So that was a constant pointer and it is to an integer constant. So if you read from here, so pointer constant to an integer constant. So I cannot modify the data, even I cannot move the pointer to any other variable. So there are a lot of variations with constants, a lot of things we can achieve using constant. Now let us see more. Next thing. So the four things I have shown you. Now let us look at fifth. I'll remove this. Now fifth thing, it is useful in classes. Let's write a class. I will call it as demo. Then I'll make everything as public and I will say integer x and integer y, two data members. Now void display. And in this function, I will simply display these values, x and some space and then y. That's all. This already we have written the class, right? Before also we have written the class. Now one thing I want to show you. I will say x plus plus, then I will display the value. And here I will try to use in class as initialization, that is, let this be 10 and let this be 20. So y as 20. So instead of assigning them, I will just create an object of demo d and I will say d dot display. Let us see what happens. If I run this program, the value of x and y will be printed, but the x value will be modified. It is a 10. So because of this x plus plus, this has become 11. Now we are ready to understand the next usage of constant. Let us learn about the constant. Now I can show you. See, beside this display function, after this I will say const. See what happens. Cannot assign to a non-static data member within const member function display. So it means that you cannot modify the members of a class when a function is declared a constant. So if you want that function should not modify the values or the data members of a class, then you should write constant. So it can only read them, it cannot write them. So the properties or the data members of a class become read-only for this function. So the constant functions cannot modify the data members of a class. That's it. So this is another usage of constant. So you can have constant functions. Now I will show you the last usage of constant. So I have to remove this. Let us see the one more usage. Here I have some data members x with value 10 and y with value 20. And I will call one function fun which will take this x and y. I have to write this function fun. So let the function be void and which takes integer reference a comma integer reference b. So it is taking two references. And what's going to do? It's going to display a and b and NL and also say a++. I have the example ready to explain you the next usage of constant. I have a function fun which is taking parameters by reference and it is displaying their values and modifying a. Now after this function call, I will try to print x and y and L. And here I will write some message that this is inside main, right? So we should know that from where it is printed. So this is inside main. Let me run the program and show you. She got the answer as 11 main, that is 11 and 20. So what is this? See, the main function was having two variables x and y. They were having value that is 10 and 20, and we have called a function fun by sending that 10 and 20. And this function has taken these values by reference and it has displayed them, that is we got 10 and 20 here, and then it has modified the value of a, that is plus plus, so this a became 11. So actually that a is a reference to this x, right? It's a reference to this x. So this x is modified, and when I display this x and y, I am getting x value as 11, right? So x became 11. So x became 11 and y still is 20. That means this function has modified a, so it has actually modified x. Yes. Now I'll come to the point. Suppose I don't want this function fun to modify this a, then I can say constant reference. If I say constant reference, it can only use that reference but it cannot modify it. It gives an error that cannot assign a variable a with constant qualified type, that is const int reference. So if you want call by reference, then usually call by reference means we want the function to modify the actual parameter. But suppose if you don't want, then still you can pass by a reference and you can make it as constant. So what is the benefit? See, call by reference functions are converted into inline functions. So it means you want this function to be inline, but the value should not be modified, so it should act just like call by value. That's it. So you can make the function inline as well as you can make it act as call by value. It can only use the values, it cannot modify the values. That's all. So many usages of constant, so you can use it properly at the right place so that it can help you